Okay, now we are going to move on to solving inequalities. So remember, the problems when they're inequalities will have one of these symbols. So if we take a look at example 5, it says solve and graph. So we're going to graph these on a number line. It says write your answer in set builder notation and interval notation. So when we solve an inequality, so for example, let's start with something basic. Let's say I had 6 is greater than 2. Okay, that's true. So the mouth of this inequality should be facing the larger number. So this is a true statement. Now, if I go divide both sides by 2, now I have 3 here, and now I have 1 here. That's still true. 3 is greater than 1. So we can divide, and again, to prove that what I'm telling you is accurate, you'd try many different numbers and it always works. If I divide both sides of a true statement by a positive, it works. It still maintains truth. So now if I go back and I have 6 is greater than 2, and this time I go divide by -2. So I have 6 divided by -2, that's -3. And 2 divided by -2, that's -1. So now we have negatives. Think about this as money. Is owing $3 mean you have more money, because the mouth is going to this, than if you only owe 1? So if you're in debt 3, does that mean you have more money than if you're in debt 1? No. It doesn't work. So we cannot divide both sides by a negative unless we switch the sign. So if we switch the sign, then it will be true. -3 is less than -1. Okay, so now you could try this with adding and subtracting. This is dividing. You could try it with multiplying. And it's a-okay to divide by a positive and not flip the sign, but it is not okay to divide by a negative unless you flip the sign. Well, that's going to be the same thing. So let's say I have 5 is greater than or equal to 2. So this line right here means or equal to. So 5 is greater or equal to 2. This is true. So if I go and multiply both sides by 3, it's a-okay. 15 is greater than or equal to 6. It works. But if I go and multiply by -3 to both sides, now I have -15 is greater than or equal to -6. That's not true. This means I have less money if I owe $15. So no, that's not true. So if I want to multiply or divide both sides by a negative, I have to flip the sign so that it works. So that is why we have to do this. When solving an inequality, solve it just like an equation. You're going to do it just like the previous 4 problems in our note packet. But if you multiply or divide both sides by a negative, you must reverse the direction of the symbol. So if it looks like that, you got to change it to going like this. You got to switch the sign. We're going to come back and fill this out when we're ready for graphing. So let's go ahead and try example 5 here. So we're going to use these steps from the beginning, our first page of our notes. Simplify if we can. So in this problem here, we can't. Step 2, we're going to highlight the variable. So I'm going to highlight where the variable is. And there's that 5 in the way there. So to get rid of 5, if I have 5, I have to -5. 5 minus 5, that's 0. That's gone. So if I put minus 5 here, I have to do minus 5 on the other side. Now I don't need to switch the symbol because I'm only subtracting 5. I only switch it when I'm multiplying or dividing. So I'm going to bring down the negative 2x, and I'm not going to switch that sign. And then here I have 1 minus 5. Or I can enter it in as 1 plus I added a negative 5 onto that side. Either way, it's still negative 4. Okay, so then we're going to go ahead and divide both sides. So that's the last step, is to divide if there's a number right in front of the variable like that. We're going to divide here by negative 2. So because of this, because we're dividing by a negative, this symbol has to now go the other way. So the steps are exactly the same as the first 4 problems we did. But if we divide by a negative, we just have to remember that one little thing to switch that sign there. So then we have negative 4 divided by negative 2 is positive 2. Okay. So it wants us to write our answer in set builder notation. So set builder notation looks like this. You're going to have these like curly little brackets like that. So these curly little brackets, that just means set. Okay, so it means the set. So this is like mathematician way of writing an answer all fancy. Okay, so that means the set. And then what you're going to do is take the variable that's in the problem. So if it was an m, you use an m. In this problem, it's an x. So I'm going to put the x, and then you're going to put a vertical line. That vertical line means such that. So what we're saying right here, such that, is the set of all x's such that, and then you're going to take this and you're going to put it right there. So you're going to copy it, the answer we got, and put it right there. So that's called set builder notation. What this is saying is x can be any number such that it's less than or equal to 2. So the number that can go into this problem for x is such that it has to be less than or equal to 2. So it says, is 5 a solution? Well, is 5 less than or equal to 2? No. So what that means is when I take the original problem that we were given, if I were to take out this x and put in a 5, it shouldn't work. That's what this is saying. It's telling us the numbers that can go in that x spot there. So according to this, it's saying, no, this is a bad number. It should not work. So let's see what happens when we check it here. So we have negative 2 times 5, that's negative 10. Bring down the 5. 5 minus 10 is negative 5. And it did not work. Negative 5 is not bigger than having $1. So it didn't work. That's what this is saying. Don't use 5. Whereas negative 6 is less than or equal to 2. So negative 6 should work then. So let's go ahead and see if it works. So if I take the original problem and we put a negative 6 here, we'd have negative 2 times negative 6. So negative 2 times negative 6, that is a positive 12. Positive 12, bring down the 5. And then 5 plus 12 is 17. And this works. 17 is greater or equal to 1. So that's what this answer is telling us. It's telling us what numbers could be plugged in for x into this original problem here. Okay, so that is how to solve inequalities. Now let's talk about how to graph it. So when we graph an inequality, you're going to take this number right here, whatever number is on the other side from the x, and you're going to put that number on your graph. Now, if you want to add numbers to your number line, you can. So if you want, so just a little review of a number line. You have 0, and then it gets bigger and bigger and bigger on the right side. So on the right side are all the bigger numbers. And then on the left side, it gets smaller and smaller and smaller, and so on. So if you want to put a number over here and a number over here, you can. If you want to put 5 numbers on both sides, I'm not picky. As long as you put this number on your graph, I'm good. You're good with me. Okay, so then you're going to put a circle on the 2. Okay, because that's your starting number here. So when you're graphing and the original problem right here, this thing right here, doesn't have the line underneath, you're going to leave the circle open. Okay, so the circle is going to stay open. But because it has the line underneath, we're going to use a solid circle. So I'm going to shade this in. Okay, so some books use circles. Now that we're in higher math, instead of using the circles, we're going to use brackets. So a bracket looks like this. So instead of putting the circle here, and I don't care if you put both, a solid circle and a bracket, but there needs to be a bracket right here. But we don't know if we're going to use this bracket or this bracket. So we're going to have to read this. This says, shade all the numbers that are less. So the numbers that are less are over here. So I'm going to shade this side here. And that's how I know I'm going to put a bracket this way. Because the bracket should open up to the numbers that are less. Okay. So when there is no line underneath, you're going to use an open circle. Or you're going to use parentheses. And the difference between parentheses and bracket, parentheses, again, you're going to use when it doesn't have the line underneath, and brackets when it has the line underneath, the inequalities. And the difference is when there's an open circle or parentheses on the number, it means that the number it's on is not included. When it has the line, it means equal to. So it means that the number it's on is included. So because this has the line underneath, it means that if I plug in, so if I take the original problem, because this is a bracket, it means if I plug in this number right here for x, so if I put a 2 right here, it's going to work. Negative 2 times 2 is negative 4. 5 minus 4 is 1. And it works. 1 is greater than or equal to, it's equal to this number over here. So that's the difference between a bracket and a parenthesis. So again, a bracket means the number that it's on, this 2, could be a solution for x. If it didn't have this line underneath, you'd have a parenthesis and it means it's not included. Okay, then lastly, interval notation. Interval notation is where you're going to put parentheses. So you're going to go from left to right. So you're going to look at the graph from the left to the right. So on the left side, it's going infinitely. So I'm going to put infinity. And the numbers on the left side are all negative. We're going to always put a parenthesis around infinity. And then on the right, it stops at 2 and it's included. So we put a bracket. Okay, so parentheses always around an infinity symbol in an interval notation. So again, interval notation is where you use parentheses or brackets and you go from left to right. You read the graph from the left to the right. So for example, let's say the graph looked like this. you would write it as negative infinity, comma, 2. If the graph looked like this, you'd write your interval as 4, comma, with a bracket, and then infinity because it's going in the positive side. These are all the positive numbers. Okay, so then let's say we had this problem. You would write this as 3 with a parenthesis, comma, infinity, because it's going infinitely to the right side, and these are all the positives. Okay, let's say we had this problem. Negative 9 with a bracket like this to the left. We'd write this one, it's going infinitely, so it's always left to right. So it's going infinitely to the negatives are on the left side. Parenthesis always goes around infinity, always a parenthesis around infinity, and then it stops at negative 9. Okay, so that is called interval notation. When would you do that? When the directions tell you to. So when the directions say set builder, it means this style to leave your answer. When it says interval notation, it means leave your answer in this style. We're going to practice both ways. So on a test in my class, you would leave your answer in the way that the problem asks.